All right. While you're getting set up, I have this where you have a nice little warm-up problem on the left-hand side. Yeah, I know I do. Okay. So please do me a favor and graph neatly the exponential function f of x equals 3 to the x, and then state the domain and the range. I'm going to record this lesson today, so I was really struggling with this lesson earlier today. I think it's because I'm getting over my sickness. But, all right, so here is what we should have come up with. Hopefully, I kind of did it ahead of time, and here's what I got. Did you guys get this? So you should have 0, 1, 1, 3. So let's talk about the domain and the range, right? What's the domain of this function? Yeah, the domain is all real numbers, correct? What's the range of this function? Y such that y is greater than 0, because there is an horizontal asymptote right down there at y equals 0, right? So you want everything above that. Oh, yeah, we'll get into that in a second. Okay. All right, so I want to go back up here to number 1. We're going to use the warm-up in the lesson, so keep that handy. So can I have someone read this to me? I got it. All right, Jonah, go ahead. Yeah, log base 5 of x. That's exactly right. Okay. And then we have this special case, which I kind of already hinted at earlier. I'm going to write it down officially. So if you have y equals log base e of x, where you take that e and put it in for the base, right, where e is approximately that 2.71. It's that irrational number. So whenever you have a log with a base of e, it gets rewritten into y equals the natural log of x. So everything that's in here is implying a log with a base of e. So that's it. So a natural log is just one special case of a logarithm. So all the rules that apply for logarithms have to also apply for natural logs, because natural log is just one special case of a logarithm. So write this down. This is the natural log. Natural log, and it comes from the whole Latin term that we talked about earlier. So that's the natural log of x. So when you see this, you read it as y equals the natural log of x. Does that help you out so far? Everyone now is on board with what e is and what the ln thing is? All right. Sorry, did I go too fast? Yeah. You guys like that? Okay. All right. I want to examine these two graphs right here and talk about the relationship between the two. This is the second box, okay? So I'm going to talk about the red graph is the function, exponential function f of x equals 3 to the x. The blue graph is the log function, log base 3 of x. So looking at these graphs here, let's talk about the one that we're kind of familiar with, the exponential function. Notice you have the guaranteed point, 0, 1. And what's the other point you can easily find? Yeah, 1, base. So 1, there you go. So that's 0, 1, and that is 1, 3. You all agree with that? So if I were to rearrange my ordered pair 0, 1, what point would I get if I switched x and y? I get 1, 0. And do you notice that point is over here? 1, 0. And then if I were to rearrange these points, 1, 3, I'd have 3, 1, which is this point over here. Exactly. So all of this, right, log base 3 of x is just the inverse to 3 to the x. So again, a logarithm is nothing more than an inverse function to an exponential function. And what's the significance of my green line here? Yeah, go ahead. That's right. It's reflected over that round. Okay. Now I want to go a little bit deeper with this concept here. What is the domain of my red function 3 to the x? All real numbers. Good. Anybody can answer. All real numbers. What's the range of my red function? Y equals 3 to the x. What's the range? The y values. Yeah. Y such that y is greater than 0. So all real y such that y is greater than 0. Because if you're saying not equal 0, you're implying negative numbers as well.
Oh, okay.
Now, take a look at my blue graph. What is the domain of my blue graph? All real x such that x is what? Greater than 0. Does anybody notice that the range of my exponential now becomes the domain of my inverse? What? Trippy. So rad. The range of my exponential function now becomes the domain of my log function. And then what's the range of my blue graph? All real numbers, which happens to be the domain of my exponential function. So tripped out, right? That's the main. I want you to understand the relationship between these two things, right? So a logarithm is not this weird, crazy, scary, math thing with a word in it. It's just the inverse of an exponential. That's all it is. That's all it is. All right. Does that help you out for that one?
You find the logarithm from just a graph of an exponential.
Yeah, you sure can. Just reflect it over the line y equals x. Yeah, logarithms are the special inverses of exponential functions, yeah. All right. So when someone asks you, 2 years from now, say, hey, what's a logarithm? You're going to say, it's the inverse of an exponential. That's $1 million question. And when you get the $1 million and you get it right, you got to give me 10% because that taught you. All right, here we go. Here's box number 3. I want to talk about the graph of the natural log of x. So look at my blue graph here. Okay. Does anyone think they can come up with the equation of this blue graph exponential, given that we're talking about the natural log of x? I got one person. I'm going to wait till I get 5. 2. I got 3. I got 3. Do I have 4? Do I have 4? I got 4. I have 4. Do I have 5? I have 5. Good. Oh, you have a question. That doesn't count. Oh, Alex, you have a question? Oh, no. Okay, let's go with you. Alex, what is... Sorry for the confusion. What is the graph of my blue graph there, the exponential?
The graph.
Yeah, what's the function? Yeah.
Oh, x equals 3.
No, it's not 3 anymore. It's not 3. What do you think it is?
I got it.
Yeah.
I got it. F of x equals,
No, exponential.
oh, it's, e.
Yes, awesome. This is e to the x, right? Notice you're really close. You have 0, 1, 0, 1, and then 1, e right there, 1, e. So about 2.71. So again, right, here's the line y equals x. If we reflect this over, the graph of natural log of x must be 1, 0, and now go to 2.71 and then go up to 1. So there you go. You got about e, 1. So they are reversed there. All right. Yeah, that's the skateboard ramp going up. You got it. Exactly. So in general, what's the domain of my natural log function? Nope, the domain for the red graph. The range of the blue graph. You got it. Yeah. Greater than 0. Yeah, because there is a vertical asymptote right at that line right there. So we can't go below 0 for a natural log function. So good question on the left-hand side. What's the domain for a log function or a natural log function? The x has to be greater than or equal. Okay, so I got some U tries. Okay, I want you to quickly, easily give me an accurate sketch with just 2 points for the log base 4 of x and the log base 6 of x. All right? Check your work with an elbow buddy. Ask them if you need to. Just the 2 problems were in box 4A and B. All right, come back to me here. You should have had these easy points, right? You should have had 1, 0, 4, 1. And you should have 1, 0, and then 6, 1. Is everyone okay with that part? All right, sweet. Let's go on. Here we go. Let's talk about finding the domains and the intercepts for gnarlier log functions. No. Just if it just asks for a log function, just a log function. Maybe some transformations if it asks for that, which we'll get to later. All right, so we got 2 problems here. We're going to find the domain and the intercepts for a log function. Now, here is what you have to realize. You want to take a look at everything that happens at the base, after the base. So here's what we have, right? We have x squared, and we want to set all that stuff greater than or equal to 0 because the domain for any log function that we have talked about is greater than or equal to 0. So when we have different things going on here, such as x squared, we just set x squared greater than 0. And you got to ask yourselves, what values of x make this inequality true? Well, x could be positive, or x could be negative. What's the only thing x can't be that would make this thing false? 0. So therefore, we find our domain by saying all real numbers x such that x is not equal to 0 in this particular case. So all you got to do is take the stuff after the base, set it greater than 0, and solve. And analyze it. Some of them you just solve for, some you have to analyze a little bit deeper. Now it also asks for the intercepts, okay? Looking at our general picture here, does it have a y-intercept, yes or no? The general one doesn't have a y-intercept in this particular case, right? But does it have an x-intercept? Yes, it does. So let's look for that one first, see if we can find it. So to get the x-intercept, we're going to set what equal to 0? Generally, how do you do it? Set y equal to 0. So that means in this case, I'm going to have 0 is equal to log base 5 of x squared. Now I'm going to do my little dance here. So 5 to the 0 is equal to x squared. I'll write that out. 5 to the 0 is equal to x squared. Well, how much is 5 to the 0? 1. Yeah, it's just 1, right? So let me pull this over here. So 1 is equal to x squared. So therefore, x must be positive or negative 1, but I know it's not going to be negative 1 because I can't go below 0 in this particular case. So therefore, my x-intercept is now at the point 1, 0. All right? Okay. So again, to find the domain, we take a look at the stuff after the base, set it greater than 0, solve or analyze the inequality. To find the x-intercept, we set y equal to 0, and we solve. And in order to do that, we have to be able to change a log form back to an exponential and then solve. Let's try another one, a little bit more interesting here. Notice I have the natural log of x minus 2. All right, first let's get the domain down. All right, so to find the domain, I'm going to look at everything that's going on after the base, right? And what's the base in this case? Nope, not 1. E, the base is E. Very good. So I'm going to analyze all this stuff and say, okay, I want x minus 2 needs to be greater than 0. So x has to be greater than 2. So my domain is all real numbers x such that x is greater than 2. That's the first part. Let's talk about the intercepts. To get the x-intercept, I set y equal to 0. So that means I'm going to have 0 equals the natural log of x minus 2. But how do I change this into an exponential? I don't see the base anywhere.
Log E.
Yeah, this is a log with a base of e. So say this, say e to the 0 equals x minus 2. You with me on that? All right, how much is e to the 0? There you go. So 1 is equal to x minus 2. Therefore, x is equal to how much? There we go. So that means that I have an x-intercept of 0, 3.
So the domain is automatically like that last part?
Yeah. You say it, yeah, you can. It'd be nice to see it a few times, though. All right, so as you guys quickly pointed out, this is not 0, 3. It's 3, 0. So thanks a lot for doing that. All right, I want to give you guys a chart for graphing log functions. So write that big nasty thing down right there, and I'll tell you what all those people. Lots of plus or minuses. Yep, that's right. All right, let's start from the back here. Okay. This plus or minus c. That is going to move the entire log graph left if that c is positive and right if that c is negative. So opposite what you think. So kind of like graphing parent functions, right? If it's inside the parentheses, it's opposite what you think it is. All right. This blue stuff over here, this plus or minus x, what this is going to do is give you, if x is negative, a reflection over the y-axis. So if that thing is negative, you have a reflection over the y-axis. That's the blue part. All right, green part here. If this plus or minus is out here, if this thing is negative, that means you have a reflection over the x-axis. And then lastly, this pink stuff.
Wait, is the C, is that vertical or horizontal?
Left and right is horizontal.
Probably.
Up and down is vertical, right? Yeah. I get confused in that too. So this B part out in the front, it's gonna go up if it's positive. It's gonna go down if it's negative. So you got this awesome little map here, this treasure map diagram thing. Maybe it's not really a treasure map. Kind of mumbling. Isn't that cool? Looks kind of pretty. I used all my colors. All right, last one here. Check this out. I'll just actually show it to you. How's that? Does that sound good? Yeah. All right. Yeah, we'll go back up. All right, here we go. Let me give you a last example. I'll just share it with you. How's that? Okay. Yeah, the question. Yeah. What do all the plus and minuses tell you in the chart? Okay, here we go. So use transformations to graph log base 3 of negative x. I know, right? So the first one is log base 3 of x. Notice I have the point 1, 0, and then 3, 1. But then I have a negative x. So that reflects it all over the y-axis. So this point goes there, and that point goes there, and I have this blue graph to represent log base 3 of negative x. Okay, last thing I want to share with you is on your calculator, I want to show you where the natural log button is, okay? Because some of the homework problems, they want you to just use your calculator to get the answer. So the natural log button is to the left of the 4. If you see the 4, look to the left. So if you push ln, if you want to evaluate the natural log of 5/3, natural log of 5/3, and push enter, and you can round to 3 decimal places. I think that's one of your problems. Yeah.
Push y equals?
Me? Yeah.
You delete that?
Uh-huh.
You push the log button?
Sure.
The base of 4.
Okay.
Then would you have to caret the
Oh, yeah. No. When you push a log on your calculator, it's automatically predetermined as a base of 10. There's a way to fix it. It's called the change of base formula. I'll teach it to you later.
How can we graph our homework without the...
No, you're going to use this, transformations. You're going to use this thing.
We could use this to check.
Yeah, you use this right here.
We could use this to check.
Ooh, you drive a hard bargain. All right, so here. What do you want to graph?
Log base 4 of x.
So here's what you do. Log base 10 of 4 divided by log of x. That's how you do it. There's your answer.
Yeah, I tried that once.
Okay. I'll show you the change of base probably tomorrow.